Fans, you'll never guess where I am today. I'm on the 7th floor, outside on a patio of the University of Malmo. Again, on the south coast of Sweden, and you're getting a little bit of a panorama now of what the local surroundings look like. What am I going to talk about today? I'm going to talk about gravity. What I have is two bottles here, bottles of water. One bottle is full and one bottle has a little bit of water in the bottom, not much. And my question to you is, which bottle falls first? When I drop them, same height, which bottle falls first? I hope you're having a guess at home. Let's watch. They fall exactly the same speed. They hit the ground at the same time. Galileo knew this 400 years ago. He could not prove it, not mathematically. That took another 100 years before Isaac Newton came along and gave us the formulation. Now, another trick. I have a plastic container here, and I have a piece of paper here. Which one falls first? If I drop them at the same time, which one falls first? You're going to guess this one, yeah? Because you'll think the paper's like this. What if I do that? Which one falls first? Which one falls first? It was the paper. Let me go back as you would have guessed originally. Which one falls first now? When the paper is now spread out. Which one falls first? And you have got it right. The top fell first. Why? What happens? There's not only gravity involved here, there's the air. The air gives a resistance to falling, so the paper spread out falls slowest. It's not the weight, nothing to do with the weight. The mass does not matter. Isaac Newton told us force equals mass times acceleration. Newton's second law of motion. He also told us that gravity, which is the force involved here, is a constant, a gravitational constant, times the mass of the thing falling, times the mass of the Earth, divided by the distance squared between the centre of the Earth and the centre of yourself, your centre of gravity. Force equals mass of the object times acceleration, equals g times the mass of the object times the mass of the Earth divided by this distance. The mass of the object cancels. There is no dependence on the mass of the object, but there is, if a thing is spread out like I showed you with the paper, resistance from the air. So, play at home. These things, how to play, there are many tricks you can play with gravity, but all in a short book I have written on home experiments. As I said, you can measure in the previous video the specific heat capacity of water. That's also mentioned in my small book. Thank you.